Hi everyone, welcome to Bamboo U. We are here at the Kukul Farm as usual, the house of Bamboo U. And here we are with Garvin and Kristof after being out there in the rice fields for 8 days, building a beautiful structure for the Balinese community, for the community here in Seabank, for the people in the rice field, the farmers. And how are you?
No, great. Tired. It's been a very exciting week, but I think this is like the third time now that we're coming here to build stuff with you guys, and it's been very, very exciting, very successful as well. Every step of the way, we always push the boundaries a little bit more, and it was really fun today to see all the prior experiments that we've been working with over the years kind of come to a next step to large scale applications in bamboo by integrating digital technologies in all kinds of aspects of it.
So you've seen that in all our projects here in Bamboo U, we get to build like very traditional construction like yurts, post and beam structures, but also a very like innovating aspects with digital technologies using rhinoceros, grasshopper, and augmented reality in few of the projects that we have been building here.
Yeah, so maybe with this, I think with bamboo architecture, especially as a building material, it offers so much possibilities for non-standard geometries. So I think we're trying to implement this in our design strategies using parametric design tools and then also ultimately augmented reality to actually construct and build it. I think the biggest advantage of augmented reality is that people who don't usually build that much can actually have access to construct something. So for the Bamboo U courses, there are a lot of people who are not trained architects. There are a lot of actually craftsmen also in Bali who cannot really read two-dimensional drawings, sections or floor plans. So normally how you would do it with physical scale models that you would have on the construction side and then scale these models up. But of course, there's a lot of tolerances and error which is occurring with this strategy. So I think now having augmented reality, which basically overlays the digital design model that you have in your 3D file, it's overlaying this as a hologram directly on the construction site where you need it. And it does this with the headsets, with the Microsoft HoloLens that we brought here, also with the smartphones. You can also visualize these building instructions, which are now holographic. And what you're then basically doing is you're creating a three-dimensional puzzle where every single component, every single step is in front of you, and you have to now match the digital representation with the physical components. So this really expands the way of what you can build, with who you can build as well.
And that journey started for us maybe 10 years ago when we did in Hong Kong the ZCB Bamboo Pavilion, this very, very large structure that was one of the first really impactful projects that demonstrated that with digital technology, you can really expand the design solution space, basically the field of opportunities that bamboo offers. Because one of the problems that you'll find with bamboo is that many people see it as like a poor man's construction material. They see it as a material that you'd use in the garden to build a shag or something, but very few people realize how strong it is and how an amazing construction material it is, being a hollow tube reinforced with these diaphragms. It has properties that no other construction material has, and it's hyper sustainable. And so trying to demonstrate that we can actually do very contemporary or different structures with that as well. It doesn't have to stick in these, tiki style beach huts or anything like that. And I think so for the past 10 years, we've been experimenting in all of our work to see how we can arrive at new types of geometries, new types of spatial experiences. And 10 years ago with the ZCB Bamboo Pavilion, there in that one of the challenges was how do you communicate on site? We tried with sticker labels and drawings, and there's language barriers and there's geometry barriers, like nobody can really visualize what a project like that would look like. And so since I think 2019 or something like that, when these lenses came out, we started to experiment first with a small scale sculpture at our university back in Hong Kong to see, can we actually do something like that? And then COVID hit, so we had to wait. But during those years, when everybody was kind of in lockdown, we kind of ended up dialing up the techniques and the methods and coming up with the whole computational workflow. And then I think it was 2.5 years now, in March 2023, when we came here for the first time to do our first experiments, where we kind of tried to see, can we actually make something permanent out of bamboo that is in complex geometry that usually wouldn't be able to easily draw or communicate, and using these holograms to get there.
Yeah. And for those of you that been here in Bamboo U or in the Kukul Farm, those are the mini domes that we use actually for during the courses. So it's accommodation. It fits 5 people, like with very nice, cozy, 5 different separate rooms. So we are using that.
Yeah. So in 5 days' time, we built 2 of those
Yeah.
with a very simple grid made from splits that was then popped up and bent into shape with a whole team of students wearing these lenses, using the phones to kind of get through it.
Yeah, I think the strategies also are now being advanced. So firstly, we used it mainly for the assembly parts, a little bit for the fabrication, but I think now, especially with the Bala Timpang project that we did this time, we actually implemented the entire workflow also for the fabrication of the structure. So I think we're gradually growing with you guys to explore these tools, to experiment more, what is being possible. So we're really excited to see actually where we can take this technology with Bamboo, with you guys in the future.
Yeah, it's been very exciting to play and use that technology, show that technology also to the carpenters here, and build all these beautiful buildings with the students. Because from those mini domes, then we jump to the big dome.
Big Bamboo Dome, yes.
Bamboo U Dome, where we do our workshops now. There's happening yoga there, carpentry station. We have a lot of lectures. We just have 120 people there attending one talk. So it's been super cool.
It's a very
like with the same idea.
Yeah, a very simple structure. Actually, it looks like just a normal shell until you realize how it was built. So we got inspired by Frei Otto's Mannheim Multihalle, which is an amazing structure that was done in '74 in Germany, where he built a flat grid and then lifted it. So what we did here is, again, in span of 5-6 days, again, with a group of students, we built this massive grid from bamboo columns and splits, using AR again to guide the process. And then we brought in a crane and basically lifted the whole thing up, had it deform under gravity, all guided by AR a little bit to try to get into its final shape. Then we locked it into place, and we basically had the fastest ever probably construction method for a dome of that size. And so that was great. What we're hoping now is that, having done this one in the rice fields here, maybe from this one there's a way to scale up as well. Just like from the mini domes here, we went to that one. So all of these projects are kind of milestones on a roadmap to who knows where we're going to end up. Very fun.
What I love is that all different projects, it's a lot of like experimental process. We also have like some things open to the process and to see how we're going to solve them like on site, with the help of the carpenters, with the insight from them, like being on site, understanding the material. Because also one of the important things to understand is, like, using a 3D model, it might work very different in reality.
Right.
Like twistings, bendings, and all these properties that with the years we can start understanding and applying that information to a 3D model so it can behave more like in a real world.
And that was fun this time around, because we came this time with 25 students from Hong Kong U. And we had 2 weeks beforehand where the students actually made scale models in the university. And so they became familiar with the workflow, and they became one of the driving forces in figuring out sequences, coordinating, and being also nimble on site and updating some of the models, figuring out new workflows, trying to orchestrate the whole dance that was basically the assembly of this project. So it was very cool to see them taking on leadership roles and coordinating roles, and with us figuring out how to do it. Because yeah, it's a mixture of skills. There's a material skill, the craft skill, but also the computational skill that kind of needs to find itself in a sweet spot in the middle. It was very fun this time.
And how do you see, like, from the first mini domes to the big dome and to this one, like there's been like improvements also like in the use of the technology, like from the mini domes to the ballet timpang, like what are like those leaps that you can feel that we can blow away?
Yeah, I think in terms of geometry, I think we are now probably at the most complex one that we've done with a group of non-experts. I think this probably wouldn't have been possible to do the first time without the experience that we gained along the process. I think also the groups that we're working with is also a bit impacting this quality. I think we're starting with this very easy pop-up grid shell, which is assembled flat on the ground. So there's not much expertise required, and especially with the AI process, you can give the task to people who really never touched something regarding architecture before. But now actually having 2 weeks before the course with the students at Hong Kong University, teaching them the AR tools, building the physical scale models, engaging them in the construction sequence, basically training them before coming here. I think this really, really helped in the process. This really gave them a certain level of expertise and ownership for the project as well, figuring out the different steps, being part of the project a bit more. Different students were leading different roles of the process. So I think this really also formed a group of teamwork to them, different kind of engagement that you have together with the team that you're building with. And then bringing that together with the local expertise with the carpenters really made that magic happen. Also, for the first time, we're using now the layup method with this technology rather than like a pop-up method. So I think that really showcases also the advantages that augmented reality has, because every single element is being visualized in augmented reality. So it doesn't really, the complexity can basically be endless with this technique, because the curves are pre-bent using these guidelines, and then they just have to be reassembled on site. So now, having tested this one, as Kristof mentioned, we can scale it up in any complexity. Now we have 2 columns, we can have 6, 7, 8, we can have 100 columns interconnecting these.
I think the interesting thing, if you would put all the projects in one go and see how we slowly expanded on the complexity, I think it's really like a tango, where you come in with a certain move and then you need to see how a site or context reacts to it. And if both parties can kind of find that balance, then you can slowly move on and create more complex movements. So I think we wouldn't have been able to do this from the first step. It's really iterative improvements, because the technology is also not per se made for this. It comes with its own glitches or its own, not even glitch, maybe just behaviors or limitation. Like every tool has a particular solution space that goes with it, and same with these AR technologies. So identifying what that is, where does it work well, where does it not work well, how do you calibrate your expectations without losing the ability to still deliver in a short amount of time, with a limited budget, with the materials that you have, like that kind of getting to know one another is very important. And they're very interesting to kind of enter into that joint space between technology on the one hand and then sustainable materials and local craftsmanship on the other hand. And it seems to be a very nice like marriage made in heaven almost. Yeah.
And I guess that the only way to really understand how those elements can merge together is just being on site, building like the entire project. So it's all about like understanding from the scale model, from the 3D model, how to do a model with bamboo also, and then going to site and really experimenting with the materials and feeling how, if we are bundling splits, how they open, how they don't bend that much, and all of that.
Now, I think what's really fascinating also, I mean, it's very rare to have an opportunity to have that dance. Like, there's not many construction projects where you have that much room to experiment, partners that want to engage in that experimentation. Like, these are all kind of prototypes or proto-architectural projects. But the lessons that you learn from it can then later on also be brought forward into other terrains. Yes, in bamboo architecture, it's kind of opening up an avenue, but the same tools and the same techniques can also open up other avenues in sustainable construction. Like, for example, with earth-based architecture, huge opportunities to apply the similar methods, the similar techniques that we have here, because again, that's also a natural material that has some variability and tolerances with it. So I think the impact from the work that we are doing here together, hopefully, is going to be able to inspire some other future avenues as well in the bamboo world, but maybe broad beyond that.
Also working with digital technologies and digital design, like the speed of the design process, it's made super fast. That I remember we were working on the 3D model, and just like by understanding like the constraints and the measurements from the land, it was like I would just like send some notes, some measurements, and in just a couple of seconds, like you were able to
file
click down, file it up. Even the geometry was not 100% finalized. We were thinking about heat bend, we were thinking about rounded poles, we were thinking about wrap rock, and all those questions, they can have a solution and they can have an answer very fast in a 3D environment. Even like scaling it down, like go to budget. So we were able to calculate based on the length of all the pieces, how much pieces we will do, have that list precisely with the lengths of each member, and just put that number into budget and see, we're spending a lot of time, because, I mean, it was very like in just a couple of weeks, like just to play with those variables and have and deliver on time.
Yeah, for that to be possible, there needs to be a strong understanding and a very good communication between all the stakeholders, because you can put any parameter in a parametric model if you want to, but in a context like this, why it works well is because we collectively have built up, I think, enough knowledge to know exactly where the crucial parameters and variables were that we need to bring in there to maintain that nimbleness, to literally 3 days before we came on site almost to finalize the type of buildup of the members that we were going to have, and to also be able to, for example, update the model a bit based on the foundations, the way they were cast on site, and the other way around. So to maintain that flexibility that Bamboo architecture demands, you cannot have a higher accuracy like you would have in a steel structure. And again, to see that parametric tools can help there as well is very exciting.
I think also parametric design in general, I wouldn't say it's per se faster to design. I think the design itself is still taking time, but I think the right word is it's much more flexible and it's much more adaptive, because once you have a parametric model, it's very easy, as you said, to change the scale, to change the dimensions. For example, for the dome, we changed the grid size 1 day before, and the entire workflow was adapted to that. For this one, we could make the changes as well regarding to the material, to the size, everything, which really allows you to respond to on-site indeterminacies and to react to things almost in real time. Because once you update the parametric model, the parametric model is then linked to the holographic display, and the holographic display is real-time screened to the HoloLens. So basically, this entire workflow, which traditionally you would need to redraw everything, you would need to reprint the drawings, you would need to bring them on the construction site. So any minor change would normally take almost days to implement. But with this workflow, you can do it in minutes, and you can have in minutes after updating the parametric model, have an update of the holographic instructions directly on your HoloLens. And this really allows you to respond, to be flexible, to really do changes on site. I think also for this one, there wasn't 100% holographic constructions, which we did before the workshop. While we were constructing, we were changing what we want to see, we were changing transparencies, we were hiding information, we were displaying information. So this flexibility in what you see, it's really, really helpful on site, because as you said, you figure out a lot while you're making it. You're learning a lot from the as-built, which can then feed back into the digital design model. Yeah. So this is really, as Kristof would say, enlarging the design solution space, I think now.
There's one aspect about this particular project that we've been talking about: technology, digital design, augmented reality, and all these elements seems to be like very like high tech and all of that. But the project itself is for the community. So after doing all these buildings for the Kukul farm here, for Bamboo U as an asset, as a place for us to work, then being able to engage with the community, get their trust to a group of people coming from Hong Kong to build something in the rice fields, and then like them lending like this piece of land, which is incredible. Like the views, the landscape is amazing, and being able to and have the opportunity to build for the community. Really looking forward to see the farmers using the space. Yes, at the end of the day, the function of this space is for them to come, rest, have lunch, store some tools there, which they already have some of these places. But yeah, it would be very nice to see how it goes.
Yeah, I think there's often a conception that complex geometry is expensive, or it's only for certain privileged groups. But I think what we're trying to prove here by going into the rice fields and targeting a local community that we're working with is to show that you actually don't need resources or extensive resources beyond what would be possible inside those communities. I mean, everybody has a smartphone in their pockets nowadays anyways, and these tools have these functionalities to load these holograms. So in principle, this can be very easily be built as long as the geometry is managed. And so what we're doing is we're using this technology, which is relatively freely and easily available anywhere, to reduce the construction complexities that are associated with these non-standard designs. And suddenly what you get is a much more engaging spatial experience, much more exciting architectural spot that can start to give meaning to a community once they start to use it. at not per se a higher cost, whether that would be in terms of time or material, definitely not the material. It's all just, it's grass that's just hanging there, or even in labor time, we just did it in 7 days. So we're trying to lower the thresholds of what engaging architecture would need. And with that, making that available, it opens up an opportunity for all kinds of innovation that can be linked to, you can do standard stuff with this as well if you want to, but by showing that you can do something radically different, kind of opens up a pathway for all kinds of ranges of innovation that you can bring in.
And what would be like, if we look at the future, like this project, it's about technology, it's about sustainability in terms of the materials that we use. It's about not just the community engagement with the people that are going to be the users of this building, but also the participants, students, that they were like also getting together to build something together. Natural materials, digital design, augmented reality. What's the future then?
I think the future is larger scale applications. Like these materials right now, I mean, we're using 4 splits that are this wide. Like it's very weak material if you compare it to what a proper Guaduacon, for example, can do. And so as we're testing out these workflows and these spatial opportunities, I think the future lies in applying it at a scale where you really benefit most from it. So being able to do large infrastructural roof projects like an airport or something like that, where you need to have these big open spaces to be able to build those with local materials, with local craftsmanship, in a local language that is very exciting as a space to be in. I think it'd be really exciting to see that becoming reality. And right now, I would guess those types of architectures are not possible because of these hurdles. People think it's too complex, people think it's too costly. But what we're proving here is that it's actually really easy, or just as easy to build something like that than it would be to build a normal shed, or just as fast, or just as cheap. So what we're really hoping to do is open people's imagination of what they actually have available, if only they'd be able to think about it.
Yeah, I think there are, for me, 2 avenues how we can see this technology having a lot of impact in the future. I think one is what we already proven with the 5 projects that we've done together now, is that you can engage non-experts in the building process, and you can engage them to construct their own living spaces without any prior knowledge to construction per se. So that is proven, showcases this direction. But the other one is actually, imagine now if you would have a group of experts, right? If you would have, instead of 20 students or 25 or 30, you would have actually 30 experts, professional carpenters using this technology. And then if we already proven that we can do complex geometries like this with non-experts or the dome or others, then imagine what would be possible with a group of experts using this technology. I think that would be the next step where we can really see how far we can push it.
Nice. Yeah, I can see like in terms of the future how architecture had been evolving, like from the traditional ways of building things, like from a floor plan, a blueprint, a section drawing, an elevation drawing, a scale model, then construction. Now we're able to like sort of like everything is in sort of like in a matrix. You start getting like information from many different places, site materials, 3D shapes, geometries, etc. Like it's in and out, moving, and then having something very, very interesting shapes and interesting buildings. I'm pretty sure that in the future, like more projects, very meaningful projects will come along with BAM.
Yeah, that'd be great.
Thank you very much again. Like we're always happy. We're looking forward to do more projects every year and keep innovating and keep like pushing the boundaries on architecture with bamboo design, augmented reality, and let's see what else is coming.
Yeah, let's start talking about the next Bamboo Build and Design course.
Yes. So stay tuned. Thank you very much. We'll keep you posted once we finish our beautiful pavilion this valley, and see you the next time. See you.
Thank you.